right, in this example, we have the graph of displacement over time. So Ella left home at 8 a.m., driving north along a long straight road, and her displacement from home is given by this function s equals f of t. So we're given s, the displacement, as a graph. And now the displacement is in miles, and the t is in hours. Hours after 8 a.m., right? So that means that 1 hour, t equals 1, would be 9 a.m. All right, so the first task is just to sketch a graph of this velocity. Now velocity is just the rate of change of displacement, right? It's the first derivative of the displacement. And so we could just look at the slope of this graph. Now, it seems to be made up of a bunch of lines, right? It's sort of a piecewise function made up of a bunch of lines, so it should be pretty easy to find the slope. So if you look at like this first segment from 0 to 1 hour, it looks like she covered 50 miles in 1 hour, right? So here the slope would be, I'll just write this down here. Slope equals 50, right? Now, if I want to graph that, it's a constant rate of change because it's just a line. So over the first hour, she was driving 50 miles per hour. Okay? So I'm just going to draw a straight line right there. That's her velocity over the first hour. Okay? And now it looks like at after 1 hour, looks like her position is just 50. So her position doesn't change. You can see that this is just a horizontal line. And when we have a horizontal line, the slope of a horizontal line is 0. Okay, so she's not moving at that point. She's not moving at all. So I'm going to just draw a little horizontal line at 0, right? The velocity is 0. Because she's not moving. She got to 50 miles and then she stopped, and then she stayed there for half an hour. It looks like. All right. Now and then she started driving again. But notice this slope is negative, right? Now this slope is negative. So, but I can see that the change in time was a half an hour, and her displacement went from 50 to 30, right? So she got closer to her starting point. So her slope, the slope here would be, it's the change in the distance over change in time. And so it looks like we need to take, she would do a negative 20 over a half an hour, right? Which is equal to negative 40, right? So that's the slope. That's the slope. All right, so now we're going to put a little line. So she drove for a half hour, so we're going to put it at negative 40, right? Now, it's kind of hard to see those horizontal lines, so sometimes what I'll do is I'll just kind of draw a little dashed line just to kind of see that this is just a, sometimes it's a little easier to see it. All right, now, okay, at 2 hours, again, she stopped, right? Because the slope here is 0, and she stopped for a half an hour wherever she was. She was 30 miles away from home, and so she stopped. I'm going to again draw a little dashed line so you know where to look. And then, okay, she started driving again. Again, she's driving back toward her home, right? So she's driving in the, she's driving back in the negative direction. So now we can just find the slope. It looks like she drove in the negative direction for an hour. And we can find the slope here. If we just look at the change we went from 30 to 0, so negative 30 over a half an hour, right? If I just take this segment from third over this half hour here. But it continues. It's just a straight line, so I could have done it for a whole hour. But the slope here is going to be a negative 60, right? That's this slope. So I can draw a horizontal line at negative 60, right? So let me just I'll put the dashed lines on here as well, just so you can see it. But I have a horizontal line at negative 60 over that hour between 2.5 and 3.5. All right. Okay. So, and then it looks like she stopped again, right? Now, you can also see too that she was driving back toward her home, but at 3 hours she was at home again. But then she kept driving. She's kept driving in and she ended up going past her home, driving past her home. So, but okay, but at 3.5 hours, she stopped again. So I'm going to draw another horizontal line there at from 3.5 hours to 4 hours. And then she started driving again. Now you can see the slope here is positive, right? So over this hour between 4 and 5, she covered 30 miles. So that means that she was going 30 miles per hour, right? But it's positive now. The slope is positive. And so we're gonna put the horizontal line at 30. Okay, so, and again, I'll kind of put some dashed lines. Now we don't know what happened after 5 hours, because maybe she's back at home, so maybe she just stopped. She's done with her traveling. Okay, so you can see that she was that this is distance from her home, right? This is the displacement from her home. And so she drove in the positive direction, but then she started driving back toward her home, right? And then she was at home, but she kept driving. So now she's going away from home. She stopped, and then she drove back home, right? Because now at 5, the displacement from her home is 0. Okay, so that's what the velocity graph looks like. All right, now this is going to be a little bit of a challenge because I have to scroll up to see the rest of the questions, and I'll scroll up so at least we can see the graphs. Okay, at least for now we'll see the graphs. And so the first question is question B, I guess, is just asking us when is Ella driving north? When is she driving north? Okay, now I guess in the problem description it says she started driving north along a long straight road, so we know that initially she's driving north. Now so this is her change. So during this first hour she drove 50 miles north. She stopped, and now notice when the slope is positive, so that must mean that she's driving south, right? Because she initially drove north. So when is she driving north? Well, I'm gonna use interval notation here instead of inequality notation. I could use inequality notation, but all right, this thing. So between 0 and 1, we know she was driving north because that's what we were told in the problem statement. So positive direction is north. And then she stopped. She's driving south. She's driving south. She's driving south, right? Because the negative velocity would mean she's driving south. But then she had to go back home, and so she's driving north also between 4 and 5. Right? Okay. So it looks like these lines with positive slope are indicating that she's driving north. When is she driving south? Well, we know when she's driving north, so she's driving south when gosh darn it. She's driving south when the slope is negative, right? So it looks like there's a couple of different places where she's driving south, anytime between 1.5 and 2, and then the interval from 2.5 to 3.5. Okay, she's driving south all of that time. She drove back toward home. She had to drive south to get back toward home. But then she passed her house and continued driving past her home. All right, when did Ella stop? Okay, well, okay, so now I won't be able to show all of this, but when did she stop? Well, it's whenever the slope was 0, right? Whenever the displacement, right? It was when her displacement wasn't changing, right? So we have several times when she stopped. She stopped when between 1 and 1.5, right? And then she stopped again between 2 and 2.5. 2 and 2.5. And then also, there's this little bit between 3.5, 3.5 to 4. Okay, so there were 3 times when she stopped. All right, at least over that interval from 0 to 5. Right now, beyond 5, she might have been stopped. She might have, when she was at home too, but on that interval was from 0 to 5. She stopped 3 times. What was her maximum speed? Okay, so notice it says speed, not velocity. So her maximum speed, right? She was going 50 miles. That's what we had with it was 50 miles per hour during this first leg, and then she's going a negative 40 and a negative 60. But the speed are going to be, if it's just to the absolute value, it's 40 and 60. And then she went 30. So it appears that the maximum speed is 60 miles per hour. Goodness. All right, miles per hour. I don't know why that doesn't stay. Miles per hour. All right, good enough. All right, so 6. Oh, and the 0 disappeared. I guess too. 0. 60 miles per hour. My gosh. All right. 60 miles per hour. All right. Well, man, maybe that'll stay now. 60 miles per hour. That's the answer. 60 miles per hour is her maximum speed. It happened to be negative, right? But speed doesn't include direction. And the negative just indicates the direction. And negative in this case is south. So, when is she driving away from home? Well, we can again look at the graph. Her initial velocity was positive, right? She was driving away from home when, during that first leg from 0 to 1. Okay, from 0 to 1, she was driving away from home. All right, and then there were a couple of legs where she's driving south, right? She's driving south but toward home. She's driving south but toward home. She gets to home. She's back at home at 3 hours, but she starts driving away from home, right? She goes farther south. So there's also a period between this interval between 3 and 3.5 where she's driving away from home, right? She's driving south, but her position is also south, right, during this interval. So, so she's driving away from home. And then when is she driving toward home? All right, well, so she's driving toward home whenever she's getting closer and closer to home. So, she's driving, when she's to the north of her home, but she's driving south, or when she's to the south of her home and driving north, okay? So we've got the interval from 1.5 to 2, and we have the interval from 2.5 to, oops, what's that gonna do? Close that too soon. All right, 2.5 to 3, and then also 4 to 5, right? So either she's driving toward home whenever she's north of her home and driving south, or south of her home and driving north. It makes sense. So, but when the displacement and velocity are the same sign, Ella is driving toward or away from home, right? So when they're the same sign, right? So she's either north and driving north, or she's south and driving south, right? So she's driving away from home when the displacement and velocity have the same sign, okay? Now, when the displacement and velocity are opposite signs, Ella is driving, okay, opposite signs, right? So either she's to the north of home and driving south, right? That would be positive displacement and negative velocity. Or she's south of her home and driving north, which would be negative displacement and positive velocity. All right, and so then she's driving toward home. Okay? Toward home. All right, that disappeared. Anyway, I don't know what's going on with this. All right. All right, I'll meet you in the next video.